Hi, good morning. I'm going to try teaching an algebra lesson this way today. I'm going to do some things up on the board here, and hopefully this will kind of help you understand Chapter 12, Lesson 5. So today we're going to try to handle something called completing the square. And it's another way that we can solve quadratic equations and to get some unique answers. What you're going to find out is that completing the square is a way that we can handle equations or solutions that we couldn't maybe solve if we were trying to just factor. So enough of that. Let me kind of start building some concepts here. Let me give you some little instruction as how to do a few problems we'll kind of build. And you watch and hopefully you can see what I'm doing on this board, and this will work out well. So the first thing I want to do is talk about how to create a perfect square trinomial. So this has to go back into your, you have to kind of go back into your mind and think about some things we did maybe in chapter 8, 9, 10. So a perfect square trinomial is something that looks like x plus 4 squared. Okay, x plus 4 squared is an example of a perfect square trinomial. If I multiply that out, if I FOIL that, I would get x squared plus 8x plus 16. Okay, so that's this expression multiplied out. Well, the first thing I want to try to do today is to create a perfect square trinomial. We're going to be given a part of this, and we have to figure out what we'd have to add to it to make it be a perfect square trinomial. So imagine if I erase this plus 16, okay? And I just had this expression, x squared plus 8x. It's not a perfect square trinomial yet. What we have to ask ourselves is, what would I have to add to the end of this so that it is a perfect square trinomial? And luckily for us, there's a shortcut. There's a little easy way to do this. And that's going to require for us to look at, in this example, the 8. Remember ax squared plus bx plus c? This 8 is the b. It's the number in front of the single x value. We're going to take that number, and what we're going to do is we're going to take b, and we're going to divide it in half, and then we're going to square it. This is what we're going to do in all these examples to figure out what we have to add to this to make it a perfect square trinomial. So half of 8, 8 divided by 2 is 4. 4 squared, 4 times 4, is 16. So I'm going to add to it a positive 16. And in all these situations, what you're adding to it will always be positive because you're squaring, you'll get a positive value. X squared plus 8x plus 16 is a perfect square trinomial. If you factor that, you'd get back to what we just had, which is x plus 4 times x plus 4. And you can rewrite that as x plus 4 squared. Okay? That's my first thing. Now let's do that one more time, because that was kind of fast. Let me look for an example over here. X squared minus 10x. If I had to figure out what we'd have to add to this to be a perfect square trinomial, again, I'm going to look at this b value, this negative 10. Notice it's negative, it's not positive, it's negative 10. I'm going to do negative 10 divided by 2, and then I'm going to square that. So negative 10 divided by 2 is negative 5. Negative 5 squared is positive 25. So I add to it a positive 25. This is always going to work. And now we'll set this way. This is a new perfect square trinomial. I could factor that out. And if I did factor it, it would give me the expression x minus 5 squared. Okay? It's the first thing I want you to think about. And you're going to practice that in a little bit. Now let me take this idea of perfecting or creating a perfect square trinomial and showing how we can use that to solve some quadratic equations. So this is sort of our second step, solving quadratic equations. I'm sure it's very exciting to watch me write words on the dry erase board on the projector screen. So, all right, so let me give you an example. x squared minus 2x minus 3 equals 0. Now maybe you could use this problem, x squared minus 2x minus 3. Maybe you could solve this problem factoring or using one of our other methods. That's okay. We're going to use this one. We're going to solve this one today by doing the completing the square. And there will be some examples, and I'll show you next, that you won't be able to solve by just factoring. And so it's good to know how to do this. To complete the square, you have to look at this expression, and right now it's not a perfect square trinomial. What you want to do is you want to get x squared minus 2x to be by itself on one side of the equation. We're going to get rid of this minus 3 and move it over to the other side. So I'm going to rewrite this as x squared minus 2x equals positive 3. Well, that seems kind of strange. We've always had it equal to 0, but when we solve it this way, you don't have to have it equal to 0. Now we're going to take this part of the equation and we're going to say, all right, what would I have to add to that to make it a perfect square trinomial? This is that trick we just covered. You look at this negative 2, okay? Take half of it, negative 1. Square it, positive 1. And we're going to add that to this side of the equation to make it a perfect square trinomial. So x squared minus 2x plus 1. Now, like any other equation, if you do it to one side of the equation, you have to do it to the other. So I have to add 1 to the other side as well. Okay? Now what we're going to do is we're going to do a little simplifying, and we're going to rewrite this as a perfect square trinomial. This would be rewritten as x minus 1 squared equals 4. Okay? Think about that. Positive 1, so 1 and 1. It has to add up to negative 2, so negative 1 and negative 1 adds up to negative 2. X minus 1 quantity squared. Now to solve this equation, we're still trying to find the value of x. So now I'm going to take the square root of this whole thing on the left side, and I'm going to take the square root of the whole thing on the right side. When I do that, the square root and the square root sign cancels out, leaves me with x minus 1. The square root of 4, and I know we had this little conversation the other day, but again, we're going to actually use both the positive and negative solutions today. So kind of throw out that thing I talked about the other day. It's misleading, I understand that. I want both answers. So when you take the square root of 4, you can get a positive 2, you can get a negative 2. So we want to write that as plus minus 2. Okay? We're one step away from solving x. We have to add 1 to this side. So x equals plus or minus, how should I write that? I think the way that I'm going to have you write it is whatever you add or subtract on this side, throw it first. So x is going to equal 1 plus or minus 2. 1 plus 2 equals 3. 1 minus 2 is negative 1. And those are the two values that can go in for x and solve that and make it true. You can check your answers if you want, but it does work. Okay? I know I'm at about 8.5 minutes here, 9 minutes. I'm going to try to do one more example for you because the next one is the one that's kind of goofy, where it's not going to be a nice, complete whole number answer. And you always have the benefit of rewatching this at another time. Woohoo! So exciting. All right, hopefully you can read that. It says x squared plus 16x plus 4 equals 0. If you looked at that equation and tried to factor it, you'd get stuck here because what are two numbers that multiply together to give you 4? That add up to 16. You're not going to find any. Okay? So we have to do a completing the square problem here. So the first thing to do is to get this part by itself. So we're going to move the 4 over. X squared plus 16x equals negative 4. And then this is kind of that whole completing the square thing. Okay? You see it? Completing the square. Okay. We look at this 16x. That's the b value. That's 16. To find what we have to add to each side of the equation, you take half of the 16 and then square it. It's always that number divided by 2 squared. So maybe over here, 16 divided by 2, square it. 16 divided by 2 is 8. 8 squared is 64. So I'm going to add the value 64 to both sides of the equation. X squared plus 16x plus 64 equals negative 4 plus 64. That's my new equation. What I have on the left side is a perfect square trinomial. On the right, we're just going to simplify that. Okay? So now look at this side. What is the perfect square root of 64? Or the square root of 64? It's 8. 8 plus 8 is 16. So I can rewrite this as x plus 8 squared equals negative 4 plus 64 is positive 60. I'm almost to the finish. To solve for x now, since it's x plus 8 squared and we have a value here, to get rid of this square sign, we're going to take the square root of that whole expression, but then we have to take the square root of what's on the right side. When you do that, you're left with x plus 8 equals the square root of 60. We're going to go plus or minus. 60 is not a perfect square. It doesn't give you a nice whole value answer. And you could type that in your calculator and get decimals. I think your book wants it in radical form. And so this is where you have to look at at 60 and ask yourself, is there any perfect squares that divide into 60? 4 can probably go in there. 4 times, 4 times 15? And I don't think anything else goes into 15. So let's do that. So square root of 60 becomes the square root of 4 times the square root of 15. The square root of 4 is 2 times the square root of 15. And don't forget, it's plus or minus. So we want to put that in front of it. Okay, so now I have x plus 8 equals plus or minus 2 times the square root of 15. That's just a simplified form of square root of 60. And now I'm going to minus 8 to this side. So I can have x be by itself. And we always do this minus or plus 8 first. So negative 8 plus or minus 2 times the square root of 15. This becomes your final answer. You can leave it in radical form. You don't have to find decimals unless they ask you specifically for decimals. That's exactly what I want. I hope that makes sense. Give it a try. You certainly can help each other out. We're going to give you a few problems to try today. First, just figuring out what you would have to add to each side of the equation. What do you have to add to make it a perfect square? And then a few where you solve these equations. And please try doing this by using this method and not just trying to do a method that you learned earlier this year. I know that'd be really smart and intelligent, but we want to learn how to use this new method. Good luck. See you on Friday.